I don't know how many people are worried about AI taking their development jobs. Maybe a couple, no one. Um, well, AI has an Achilles heel, and that is AI has to be trained. So if you're a developer and you want to get into you want to stay a developer, you should probably focus on doing things uh, that haven't been done before, greenfield projects. IoT is one of those spaces where um, there's only 2 or 3 different items for every idea, as opposed to the internet where there's thousands of items for every idea that AI can train off of. So I'm going to get started here. First, this is my company Data Messenger, and they're be using some Data Messenger products. And of course, I'd like to thank Southwest Florida Coders by Southwest Florida. And FIRST is a group that I mentored with. FIRST inspires, basically, they get kids involved in STEM, science, technology, engineering, mathematics. And if you're a STEAM person, they also have some art stuff too. So I'm going to be talking about the intranet of things. Normally we talk about the Internet of Things. The Intranet of Things is kind of a phrase that I'm trying to push, and we're talking about building UIs for IoT with React and Raspberry Pi. And basically, the Internet of Things is these sorts of things in your house, right? In your businesses. What I call land first development. So it's for your local area network. Your light bulbs are intranet of things. Your camera phone or your camera security systems are kind of an internet of things. They really expect you to go to the internet, but there's really no reason for your light bulbs to be involved in the internet. So I call that an intranet of things. And these are the things that do locally useful work. They're controlled locally. They're useful to other local devices and things like that. Now here's a graph that I created to kind of help visualize where I think IoT is in respect to other areas of development. So using some statistics from Statistica, these are a couple years old now, but the 68 million annual users of owners of PCs, there's 74 million people buy smartphones. Those are those two small slivers in the pie chart. The next big sliver there is what I think of the Internet of Things, because the Internet of Things is a lot of devices. These are lots and lots of devices. The Internet of Things is way bigger. This is my interpretation. It's way bigger because every light bulb, every toaster, every toothbrush, all stuff that's Internet of Things. And these are all things that need user interfaces. They need a way for you to connect with your phones locally, they connect with your laptops locally. And if you need to connect over the internet, you can still do that. But they all need these interfaces, and they're not the same. They're not built the same way that your web interfaces are, but they can be built with the same tools. And one of those tools is React. There's of course different protocols for how Internet of Things work. There's Wi-Fi, which everyone's familiar with, Bluetooth, Zigbee, which is kind of a low power offering. It's very low data transfer rates. And some of these other frameworks for the Internet of Things, AWS and Salesforce, they all have some way to connect to an IoT device through the internet. But we're going to be talking about Internet of Things. So right now we're going to be focusing on Wi-Fi. Matter is a kind of a brand name. You'll see it on a lot of products coming out now, but they use an API. So it's an open source API that you can use to build applications against, but you kind of have to use their API. If you have a new idea or a new product that you've developed, they probably don't have an API for that. In fact, early on, they didn't even have an API for for shades for windows, even though some of their early backers made electric shades for windows. Of course, here's some single board computers. Probably familiar with Raspberry Pi. There's Latte, Panda, Intel NUC. These are fairly powerful little computers. I'm going to spend a lot of time talking about these, but right now this is an Raspberry Pi 5, Model 5. I could run this on a 0 if I wanted to. The 5 is a little better if I have to do a graphical interface, which I had to set this up tonight. But like the Pi 0, you do a system D file and it loads automatically. You can do completely headless application. Here, of course, some microcontrollers. Arduino is a very popular choice for microcontrollers. I currently don't work with Arduino except for if they can run Python. Certain flavors of Python will run on Arduino. Raspberry Pi Pico, of course, runs Python. And I'm using sockets. If you're not familiar with sockets, I'm just going to do a quick primer on sockets. Internet protocol it uses TCP, transmission control protocol, and that's generally what we use when two devices are talking to each other, and they're well known to each other. What we're using when we're using our browser. And then there's UDP, User Datagram Protocol, and that's for discovery. If you don't know who something is, you want to broadcast some information just to everyone who might be listening to you to use UDP. Here's a graphic that shows those IoT services will connect to your TCP client. That TCP client connects to a TCP server and then back to another IoT device. This is how it might work with UDP. So you have on your right, you have an IoT device that's out there, and on your left, you have a service that doesn't know about it. So it starts listening using its using a UDP client. It starts listening to messages being broadcast by the IoT device, and once it discovers it, then it goes back and it makes a TCP connection directly to it. And that's basically the 10,000 foot view of IoT and how it works in a local area network or in Intranet of Things. Now, project that I've got here, I started thinking about let me back up a little bit. Back to the screen. So the project I got here, I started thinking about, well, what's a good Intranet of Things device? Something that would demonstrate the capabilities of what you think about when you think about these kinds of devices. And there are so many little things, but one of the ideas that I like to think about is that every device can be unto itself. It doesn't necessarily have to know what its greater purpose is in the world. Other devices can figure that out. And a good example of that is a thermostat. When we think of a thermostat, it's on the wall, it's one little unit, and it's all together. It's got a little sensor in there for the temperature. It's got the little readout on it. You can program it. It's all in one spot. The problem with that is if you're like my house, if at certain times of the year your bedroom is boiling at night and your hallway is freezing, and other times your bedroom's freezing, the hallway is boiling because the hallway is where the thermostat is, right? So wouldn't it be nice if you could put a temperature gauge in every bedroom and maybe every room of your house, and then you can have a computer a program that figures out, okay, it's nighttime, people are sleeping. I'll average the temperatures in the bedrooms and I'll use that, and I'll forget about the hallway. Or maybe maybe it's during the evening, people are in the living room, so it'll use the sensors in the living room. It'd be kind of difficult to wire your whole house for that in advance. But with IoT, you can build a device that does that. Every little sensor then has a purpose for that thermostat. Now, there's a whole bunch of other uses for those sensors as well. There's no reason that a temperature sensor has to only be used for your thermostat. You could use it for historical data in your house to figure out what your energy usage is. You could use it by your window shade. You might say, hey, it's hot in this room, close a window shade. So being able to discover all of these devices within a network and then use them is really a job of a programmer and someone who's building a front end. If you can say, hey, I know I've got this sensor, I know I've got this house, the sensor says it's in this room, the sensor says it's in that room. Now I can figure out some interesting things that I can show on the screen that someone can do with this nice little app that I built. And so that's where I'm going with this. So what I have here is an IoT representation of that. Now, because of the constraints of this environment, everything is actually running on one computer, but it's all actually modular. And all the components, they don't actually connect to each other directly. They connect to each other through a database. So the temperature gauge just sends data and it says, here is my data. And it puts it in a database. And then the thermostat says, here's a temperature gauge. This is what it says the temperature is. And it responds to that. And it sends a message to the database to a relay that's sitting on that database, and it's telling the relays to change your state to on in response to my command. So the relay doesn't really know anything about the thermostat, and the temperature gauge doesn't know anything about the thermostat, but the thermostat does, and it coordinates all of this stuff. Now, I've got a little tool here that apparently I turned off. Just a minute. Hey there. This is an application I've been working on. It's called DM Studio, and it connects to a database that I've made for IoT. The database is kind of in alpha. If anybody wants to get an early release, just come see me afterward and you sign up your name, and I'll send you a link and email as soon as it's out. And it lets you develop applications using Python or Java or JavaScript. Right now, I'm working on trying to modularize the JavaScript part to make it play better with React and Node and all those things. We've done it, but it needs improvement. Anyway, so what I'm going to do right now is I'm going to connect to this device. Now, if you notice this code right there, that's a UDP IP address. There's a whole range of addresses that are basically reserved for UDP, and that's one of them. And this is just a port that my device is going to be broadcasting on. So I'm just going to listen for a database called Coders. Okay, found it. Now, one of the problems that you have with IoT devices is that every device has its own idea of what data looks like. Um, you know, some devices want tables. Some devices are very simple configuration files. Some devices might be a lot more sophisticated. Uh, so this database accommodates a wide range of preferences, and it does it using an interface that's fairly fairly intuitive, I think. So if we that done. So here I have a set of devices, and they're all set up as objects. I can find my objects over here in this manifest, and these are the different objects I have, and these are all the different fields that are available to me as a developer. But if I go over to my database, this is the data that's available. So I'm going to first, I'm going to look at my thermostat and see what the settings are. Thermostat. Okay, so it's saying it's set in heat mode and it's set to 60 degrees. So I don't know if any of you can see this. There's a little tiny red light, means the heat is not on. So say if I want it, but the temperature, if I look at the temperature, I can go over to my temperature sensor. A little bit of latency. Now my temperature says it's 24.6 degrees. Now that's actually in Celsius. I'm storing my data in Celsius, but I'm saying that I want to convert it to Fahrenheit when someone uses it for when I store these records. But right now it's in Celsius. So I'm going to go back to my thermostat. And I'm going to try to change. Change this to 80 degrees. Okay, now if you've noticed, there's now a green light down here on the table. If anybody wants to right now, come over here because I won't be able to do this later on during the presentation, but you'll see that it actually has the Fahrenheit displayed on our thermostat, and the light's now green because I'm trying to heat the room to 80 degrees. Now, if I want to change my mode here from heat to cool, and I want to cool the room to 80 degrees, and it's only 76 in here, as soon as it figures out that the mode has changed, it's now gone off. Now it's set to cooling, and it says, well, I don't have to cool because I only want it to be 80 degrees here in my database, and the actual temperature is 76. Now the readout, the digital readout isn't coming from the thermometer. The it's coming from the thermostat. The thermostat has a connection to the readout, and so the thermometer has no idea what temperature is being displayed. And essentially, all you have to do as a developer is write a program that changes a value in the database, and the device responds out according to. Well, I'll show you I'll show you the code that I used to write this program. This isn't that sophisticated, but it could be. Not a hard development to just say, okay, if you look over here, where the temperature sensor is, there's only one, and it's only indicated by 0, but I could have 100 there, and then my application would simply average from 100 instead of 1. And if you look at the actual sensor, and this is my object. A person might develop their own objects, but in my object, I'm saying a device has a room that it's in. I'm saying it has some sort of code that tells them what kind of device is being used. Just enough information so that when I do some discovery, I can say, okay, that's the model number of the device, it's the room it's in, and that's a brief description. So if I wanted to look for all the room temperature gauges, I would just search for room temperature. If my thermostat is, for example, in the conference room, and it wants all the temperature gauges in the conference room, it would just use its own name as a search parameter. Okay, so what does this look like to the developer? Now, I suppose I could open up another application here. I'm going to close this one. I'm just going to turn it off. Okay. Going to do a React application. Essentially does the same thing. I'm using NetBeans here, by the way. Any fans of NetBeans, I'd like to meet you. I think there's only two of us out there. And this is what the database is called InclusiveDB. There's a good history behind that name. I'll probably going to cover that another time, but it's obviously synonymous with this area. So. So in this case, I could not use UDP because this is JavaScript, and JavaScript doesn't have that capability natively, but Node does. There's Node libraries that can use UDP, but this is just running on my browser, so I had to know the IP address of this device. Essentially, this is the same interface, but for some reason it works better. If I go to my thermostat, there again, there's my temperature of 80 degrees. The mode is cooling. If I change this back to say 50 degrees, hit an update. There it is. So anyway, now the light's green because the temperature is 50 degrees. So I've changed it from my React application running in a browser on a local network, which means you can put it in your phone, tablet, put it anywhere. Now, I was going to show you some code for doing this with a React. It's pretty tricky. It's a lot easier to show you with what's going on with Python. So anybody wants me to go through the React specifically, or would you rather see the Python? Is it no preference? Okay. Anyway, this is actually one of the reasons this is a little faster is it's not using the traditional WebSocket. It's using it's not using a traditional TCP/IP connection. It's using a WebSocket connection with the browser. The database itself has its own WebSocket server, so it's easy to configure to work with this with a browser. Let's see, I'm just going to exit out, and I'm going to change applications to this is Eclipse. So NetBeans used to support Python. They don't really support it anymore, but Eclipse, so I use Eclipse for Python. There's actually tools that come with Raspberry Pi that are pretty nice for developing if you just have to do an application that's got to work on your Raspberry Pi. It's not as robust. I recommend that if you want to do development on your Raspberry Pi, get the Pi with the most memory. Spend the extra $20, get the 8 gig memory. You'll need it. So let's take a look at this digital thermometer, and this is the coolest feature of Eclipse is I can just make it bigger. So we'll start down here at the entry point. This is the main for the main entry point for the application. If you're familiar, anybody not familiar with Python? Not familiar? Okay. All right. So first thing I'm going to do up here is I'm going to create my client, and this is what I'm going to use to connect to my database. In this case, this code will be running locally on the Raspberry Pi, so all I have to do is connect to localhost. I don't have to, it's going to use the default port, but if I had to specify a different host or a different port, this is where I put it, is in this method here. And then I'm going to set the connection interrupt. This is in milliseconds. I'm going to set it to 10 seconds. Just because it's Raspberry Pi, sometimes it doesn't have enough power. So I want to give myself every chance to connect before I give up. Default is 5 seconds. That's usually good enough. Then here, I'm going to open my connection. Use my super secret password. And that's pretty much it. If you notice, I've got it commented out up here. I don't know if you can see that, it's pretty small. Hold up. I could set it to use a user session. User sessions are great if you're doing a lot of processing because you don't have to validate every time. You can just send that a token over. It's not necessary if you're running a local. It's a little more work. You're having to validate, but it's local, so it's really quick, and it doesn't expire. You're not using a session. If you're using a session, it's going to expire. You can set the session to expire a long time in the future, but you don't want your air conditioner to stop working at some arbitrary point in the future. Okay, so the next thing I do here is I've got a couple objects I've created. I've got my thermostat object, my network sensor, and my network AC object. And now these are all running locally here, but in the field, another application, they could be running separately, and they would just do discovery to find each other. And then I start the threads for each of these items. It shows they're all actually operating independently. Now I'll show you how the first one works here, this network thermostat. It's up here. I've got an object I'll go through this as a base object. I just call it network device. And it holds my room, the name of the device, a room number, and a couple little bits of information. It has one particular method called get local device by name. So it looks at its own room number and says, are there any devices in here with this particular description? And then it provides some methods, just helper methods. So network thermostat is a subclass of network device. And first thing I'm going to do is I'm passing in my connection that we made. And I'm going to take that connection. It's getting passed in to my network device up here. And then I'm going to call this method, and I'm going to get the information from the database for my network thermostat. And that's what this data is. Now I'm going to unpack that information down here into my object. For the IoT stuff, I have to create a 7-segment display, which I did just because it was fun to do. Probably wouldn't use one. And one thing I like to do is I like to create a key for my database, so I can get that data directly out of the database. The way this database works is a little different. Every value in a table or object has its own key. It would take me an hour just to go through it all, but it's pretty simple. You just get a key, and then you can resolve that key against a path to get to the data. So I'm getting the main key for my thermostat right there. And then I can just select that key, and that's going to give me all of my temperature data, my scale data, my mode, and my drift. Drift is just my term for the difference between being right on and maybe waiting a little bit before you go off. It's the drift. So your air conditioning doesn't shut off as soon as it turns on. So there I've just populated my thermostat object. And then later on, this whole thing starts running. The first thing it does right here is it creates a couple local references to its thermostat, and it checks to see if it was on. And these are just basically, thermostat things, not necessarily code things. I'm going to select my thermostat. I want the most recent data. I'm polling my thermostat, so I'm going to select the most recent data using my key. And then I repopulate my thermostat with the new data. And then I'm going to check to see if I have a key for my sensor. If not, I'm going to get that. And if I do have the key for the sensor, I'm just going to use it to get my temperature and set that on my thermostat. Then I have another key. I want to see if I have a key for an AC unit. I'm going to check to get that. AC unit key. And since the AC unit, I only really need one thing, state. So I'm going to basically resolve my AC unit key to the state key. So I can just have one key that I'm just calling all the time. I don't have to do this again. And so if I do have a switch, it's gonna set the value in the database using my connection. I probably should have written connection, sorry, but put C. So connection is C. So I'm gonna go to my connection and I'm gonna set using my switch key that I just made, the state, and it's gonna get the state from the thermostat. The thermostat, whatever the settings are, it's gonna say I'm supposed to be on or I'm supposed to be off. And it's just gonna set that on the database. And if you notice, I did a little trick here. I created a Boolean up here, is on. That way, if it was on and it's still on, I'm not gonna waste time with the database. So I do a quick little check there. If there is a change, then I'm gonna set the do change on the database. And then at that point, the switch application, all it does is it just looks for a change in its state and it polls the database. Has my state changed? If its state's changed, then it changes. What's interesting about this with a distributed database is you aren't actually using your network bandwidth, because you're in a database where everything is on one machine. You would have to be sending signals across your room, across your house all the time. But if it's a distributed database, the part that's holding the data is on the same device where the action's taking place. So when it's polling to see if it's supposed to go on over and over again, it's only polling its own file on its own machine. Interesting. So that's the code. Is there any particular code you guys want to see? Do you want to see the code on, for example, the actual thermostat? I could show you the thermostat code. Devices, thermostat. Like I say, this is pretty quick. Hacked it together, you know. Didn't take a lot, and it's oddly, it's pretty robust. Had it on for a couple of days and it's been working for one of them. So it's pretty good. And there are some code that's more tricky. I basically found this one online for the sensor, the little temperature sensor right here. If you just breathe on it, it'll change the temperature. It's very sensitive, but it's actually kind of elaborate on how it works. Here's all the code for it, just to get a reading from your temperature sensor. So I'm glad I didn't have to write that. We can credit Zoltan up here for it. So that's basically it. We're at time. So any questions? Anybody want to run out and build an application for IoT and Raspberry Pi? That's what I'm hoping to see. Is this different or about what you expected? Yeah. Okay. Okay. Well, I have some, if you guys, I know this isn't going to be on the camera very well, but if you guys want to come over, I would show some items that, if you're interested in IoT. Sorts of things you can do. So there, there are 36 little components in here. All of them are sensors. They all do different things. They, from temperature to humidity to fire to smoke to lasers. You wouldn't believe what this costs. Anyone want to guess? $20. $20. So this is a lifetime of projects and writing code. And the problem is you want to do one of these projects. The last thing you want to have to worry about is how do I connect this project to my other project? If you write it to where it uses a database, then you never have to worry about that. The database handles the connection between your devices by not connecting it, connects them through data. This gives you an idea of how wild you can get. So I want to do a 7-segment display, but I figured no one could see it. So I bought a couple of these. You can, it's all online. You know, this was a little pricey, it's about $8. But it works exactly the same as that. You plug it in the same wire, same code. Other items. Anybody seen a Pi Zero? You all seen Pi Zero? It's got a chip in it. This is a little project case that it comes in. It's almost the size of the actual Zero itself. So you can handle it while you're working on it. And the cases are, I mean, the Zeros are so inexpensive that the cases are almost as much as the Zeros. You can get them between $4 and $5 for a decent one. Some of them come with kits. If you've never bought one before, you're thinking about buying one, I recommend the kit because nothing on those connects to, all those little connections have to go to something, and they're all custom. They're all very small connectors. You probably don't have them in your toolbox. So you buy a kit, you get a switch that plugs in, you get a HDMI that's the right size. You know, you get the, sometimes you get the power supply, depending on what the kit is. But I recommend spend a couple bucks extra, get the kit at least for the first one. But little device like that, you know, is just as powerful for doing this kind of work as the Raspberry Pi. And it'll run the database. The database itself has one requirement that's heavy requirement, that it needs to have Java running on it. It doesn't need a particular great Java application. Could use the standard Java. It doesn't need Java FX. Here's some things that make that also are kind of interesting. These are relays. You can power that one right there. Can power it's actually these are also what are called single pole double throw. because they have one wire is always on when it's off. And the other wire, you know, so you can actually have something like this where you have a green light when it's on and a red light when it's off. Well, how do you get that? Single pole double throw. And what's great about the single pole double throw is it physically cannot be both. It either has to be on one way or on the other way, the same lever. Yes. How many people have seen a Pico? 5 Pico? Okay, so I use the supplier. There's a lot of suppliers out there. Supplier called Newer on here. They supply industrial quantities. They will also sell. They sent this huge box. Huge box. Pico is acting with microphone and that's Pico. So put these together. 0. And even my database, you can't run the database on here, but it can connect to the database and store data. So, center. Let's say that's I pay extra. Yeah, I can call it. Unless anyone wants a primer on how this database works. Like I said, that's a long story. Although it is small, like I say, it takes, Java has about 10 megabytes or 10 gigabytes of overhead. But the entire database fits on one jar file in half a gigabyte, so 500 megabytes. So it's pretty small. And it generally doesn't take a lot of power to use it. It does take more memory than, say, a relational database of like TinySQL or something. But its value is that you can put different kinds of information into it. Like you say, I show you objects there. I guess I could show you. So if you look here, this looks like just a regular configuration file, right? This is the configuration file for a server. It'll generate this. I could just click on it. I could say new server. I give it a name. It generates it. But all of this data is stored in the database. But you can see it's different. It's a lot of different kinds of data. So, and what's really interesting is that all of the data in all the databases can be shared. So if I open this up, this is what it looks like. It's the same. It looks the same as what the application looked like in the IoT application, right? Same metaphors, same devices. You can click over here on the manifest, and you can see. You can see whatever objects are available in that database. This file format is the file format for the database. So you can store any kind of information in this. And what's interesting about it is that it stores with type. So you can specify that it's an integer or a long integer, float or double. It has a counter object, so it has a built-in atomic counter. So if you need to, if you're checking, visitors on a website or something like that, and you just want to hit that counter and increment your database, you can do that too. And it has most of the types you would expect, different things like, date types and things like that. One of the types that it actually has itself as a type. you can serialize stuff as a data set. So you could take the entire database and ship it, or you could just take a single node on the database and say, I would just want to ship that someplace else, export it. And then you can import that in this using this tool anywhere. This is again, a different configuration. So you can change, if you think about what you can do with React components, all this can be done with React. Now, this is done with Java FX. To run this, you just need Java FX and Java. If you don't like to pay for a license for Java, which most people don't, there's a number of sources of open source Java out there. I use a company called Bellsoft, and they have a really extensive, really easy to use distribution. They compile every new version, they fix any bugs, and then they have an enterprise version. But I found their stuff to be pretty good, and I know that some of the install people who build executable install applications use them as their default when Java is specified. So. I can get into specifics about how the database is partitioned. That would bore you to death out of the field, but that's pretty much it.
Questions? All right, thank you, Jon. Thank you. All right, so I'm going to go ahead and end the recording now. And then also I am going to end the stream. Thank you very much to everybody who joined us on Zoom. And Have a great night.